Good morning, everybody.
Good morning.
All right. Yesterday, Mr. Trent gave us a little presentation on network troubleshooting. Before you can troubleshoot that stuff, you got to have something to troubleshoot, which is in our course. We have routers and we have switches. Does anybody know what a network switch is or used for? Nobody don't know. We're in this technology, we don't know. A switch is a device in a computer network that connects other devices together. Multiple data cables are plugged into a switch to enable communication between different network devices. Switches manage the flow of data across the network by transmitting a received network packet onto the one or more devices in which the package is intended. Each network device connected to a switch can be identified by its network address, allowing the switches to direct the flow of traffic, minimize the security and efficiency of the network. You can look at your handout about common connection devices to learn a little bit about the hubs, bridges, switches, and wireless access points, and more information.
Networking is the word people use when they're talking about connecting computers together so they can share data with each other and all connect to the internet at the same time. Let's take a closer look at the key components that make up a simple, easy to set up network. Think of a network as something similar to your body's central nervous system. At the top of the network is a brain that handles all the traffic coming through. This is called a router. The brain is connected to a spine that sends signals throughout your network. This device is called a switch, and it distributes signals to all of your computers and devices via network cables. Now let's check out each of the components of a wired network in more detail. We'll start with the router. A router has a smart little computer inside that identifies all of the computers and devices on your network and assigns a unique number to each one. Techie people call this an IP address. A router also connects to the internet outside your home via a modem that can be provided by your DSL or cable internet provider. A router is always at work, managing the tons and tons of information your computers and devices send and receive, and controlling which computers and devices get what information and when. So how does a router actually send information from the internet to your computers and devices? And how does it enable your computers to share information with each other? The answer lies with that device we mentioned earlier, a switch. A switch sends traffic through your network to the places it needs to go. Every Netgear home router has a switch with 4 ports built right into it. You can also get wireless routers from Netgear that use radio signals to do the same thing as a switch, but these still have those 4 ports built into them, so you can use wires with them too. When you're buying a router for use in a wired network, pay attention to the speed of the built-in switch. The fastest switches are called gigabit, and they're perfect for applications like streaming video in your home. Meanwhile, routers with switches called fast Ethernet are great for essential tasks like web surfing, email, and online gaming. Now say you have more than 4 items you'd like to plug into a router. You need more ports. The solution is easy. You'll need an additional switch, which again is that thing that's already built into your router. In this case though, you just need the switch portion and not another router, because your network doesn't need 2 brains after all. Netgear has switches with as few as 5 ports, as well as some that feature 24 ports or more. Once again, if you need the fastest speeds, go for a gigabit switch. Your Smarty Pants Netgear router will recognize these new connections and start sending data to them right away. Here's one more thing to keep in mind. Some people often confuse a switch with a related device called a hub, which is obsolete. You just need to know that hubs were replaced by switches because switches do the same thing, but with a lot more speed and smarts. A router, a switch, and network cables all come together to create a fast and reliable wired network that works a lot like your body's nervous system. Fortunately, you don't have to be super brainy to understand how it all works.
A network switch is a multiple port network bridge that uses hardware address, the MAC address, to process and forward data at the data link layer, layer 2 of the OSI model. Some switches can also process data at the network layer 3 switch by additional incorporate routing functionality. Such switches are commonly known as layer 3 switches or multiple switches, a router switch combo. Configuration options. You've got a configurator. Go into that troubleshooting that Trent gave us yesterday. On the table, you'll see some unmanaged switches that are used in residential houses. An unmanaged switch simply allows Ethernet devices to communicate with one another, such as PCs or network printers. And those are typically what we call plug and play. Unmanaged switches simply allow Ethernet devices to communicate one with each other. They are shipped with a fixed configuration and do not allow any changes to this configuration. Also on the table are some managed switches. You'll see every day in a network closet or in a rack system. Managed switches have one or more methods to modify the operation of the switch. Common managed methods include command line interface, access via serial consoles, telnet, or secure shell, an embedded simple network management protocol, SNMP, agent, allowing management from a remote console or managed station, or a web interface for management from a web browser. Examples of configuration changes that can do from a managed switch include enable features such as spanning tree protocol or port mirroring, setting port bandwidths, creating or modified virtual LANs, which we call VLANs.
In this simulation, we look at the basic operation of a switch. Computer 1 sends a ping to computer 3. When the ping frame reaches the switch, unlike a hub, reads the data in the frame. In particular, it reads the source and destination MAC addresses. The switch looks up the destination MAC address in the switching table. In this case, it finds that computer 3 is connected to port 3, so the switch forwards the frame out port 3. Computers 2 and 4 never see the ping frame. When computer 3 receives the ping frame, it sends a ping reply back to computer 1. When the frame reaches the switch, again the switch consults the switching table and finds computer 1 is connected to port 1. The frame is forwarded out port 1 and is received by computer 1.
Typical management features: enable and disable ports, link bandwidth and duplex settings, quality of service configuration and monitoring, MAC filtering and other access control features, configuration of spanning tree protocol, and shortest path bridge features, simple network management protocol, monitoring of devices and links health, port mirroring or monitoring traffic or troubleshooting, link aggressive configurations to set up multiple ports for the same connection to achieve higher data transfer rate and reliability. VLAN configuration and port assignments including IEEE 802.1q tagging, network access control features such as IEEE 802.1x, Internet Group Management Protocol, snooping for control over multicast traffic. The most common configuration is the virtual LAN, VLAN, in any broadcast domain that is partitioned and isolated in a computer network at the data link layer, OS layer 2. LAN is abbreviation for local area network, and in this context, virtual refers to as a physical object recreated and altered by additional logics. VLANs can be used to create broadcast domains, which eliminates the need for expensive routers. Theoretically sensitive data may be broadcast on a network, in such a case placing One of those users who can have access to the data on that VLAN can reduce the chance of an outsider gaining access to the data. Here's a video explaining how a VLAN is used.
VLAN stands for Virtual Local Area Network. A VLAN is a local area network where the computers, servers, and other network devices are logically connected regardless of their physical location. So even if these devices are scattered in different places, it wouldn't matter, because a VLAN can logically group them into separate virtual networks. And the purpose of a VLAN is for improved security, traffic management, and to make a network simpler. So as an example, let's say you have a 3-story office building, and in this building you have computers that belong to certain departments that are mixed in with computers that belong to other departments on the same floor. So the red computers represents the accounting department, the blue computers represent the shipping department, and the green computers represent the support department. Now, as you can see, all these computers from these different departments are all connected to a switch. So they are all on one segment on a local area network, or LAN. So all the network broadcast traffic are mixed in with other departments. So the departments are all seeing each other's network traffic. Now suppose, as a network administrator, you wanted to separate the network broadcast traffic from these departments from each other, so that the accounting department doesn't see any traffic from support, support doesn't see any traffic from shipping, and so on. So in our example, the VLANs were created on the switch. And this is done by designating specific ports on the switch and assigning those ports to a specific VLAN. So on the switch, we'll create a VLAN for the support department. So we'll plug all the computers that belong to the support department into those ports. Then we'll designate another set of ports on the switch and create another VLAN for the accounting department. And finally, we'll designate another set of ports on the switch for another VLAN for the shipping department. And as you can see, the network traffic is separated between the departments because of the VLANs. So, as stated before, there are several different reasons for creating VLANs, but one of the main reasons is for traffic management. Because as a local area network grows and more network devices are added, the frequency of the broadcasts will also increase, and the network will get heavily congested with data. But by creating VLANs, which divide up the network into smaller broadcast domains, it will help alleviate the broadcast traffic.
SOHO is short for small office, home office, which we all typically have at our house. A team that refers to a small or home office environment and the business culture that surrounds it. A SOHO is often thought as being the smallest of small businesses. It is a privately owned and operated business or individual who are self-employed. SOHO is often categorized as being a small in both the size of the office space and the number of the employees. As a general guideline, a small office is considered to be any firm fewer than 10 employees. Although in the more recent years, some research and marketing firms have taken to categorizing SOHO as a firm of 1 to 4 employees. Firms with 5 or more employees are considered different categories with a small business sector. The network switch plays an intelligent role in most modern internet local area networks, LANs. Mid to large sized LANs contains a number of link management switch. Small office, home office, SOHO applications typically use a single switch or an all-purpose device such as a residential gateway to access small office or home broadband services such as DSL or cable internet. In most of these cases, the end user devices contains a router, and components that interface to the particular physical broadband technology. User devices may also include a telephone interface with voice over IP. Connectivity. Unshielded twisted power cables are widely used in the computers and telecommunication industrial as Ethernet cables and telephone wires. In the UTP cable, conductors which form a single circuit are twisted around each other in order to cancel out electromagnetic interference, EMI, from exterior sources. An RJ45 is a type of connector commonly used for Ethernet networking. Since Ethernet cables have a RJ45 connector on each end, Ethernet cables are sometimes also called RJ45 cables. The RJ in RJ45 stands for registered jack, since it is a standardized network interface. RJ45, which intentionally stands for registered jack 45, is the Ethernet style data port found on switches, routers, and network cards. The RJ45 style connectors and ports are also commonly found on Ethernet serials and ATM-IMA cards and interfaces. These are commonly referred as Ethernet cables. If you want to look at your paperwork, the UTP fiber and 802.1x handout, a computer network engineer, an internet standard, and a normative specification of the technology of methodology applications to the internet. Internet standards are created and published by the Internet Engineer Task Force, the IETF. On your second page is the optical fiber section. A fiber optic cable is a network cable that contains strands of glass fiber inside an insulated case. They're designed for long-distance, high-performance data networking and telecommunication. Compared to wired cables, fiber optic cables provide higher bandwidth and can transmit data over long distance, and additionally, fiber are immune to electromagnetic interference, a problem from which metal wires suffer excessively. Single mode means that fiber enables one type of light mode to be projected at a time, while multiple means that the fiber can project multiple modes. The difference between single mode and multiple mode fiber mainly lies in the fiber core diameter, wavelength, light source, and bandwidth. Look on page 3, optical fiber transmission database section, where a single mode fiber cable speed, no matter the data rate, at 100 megabits or gigabits. The transmission distance can reach up to 5 kilometers. In that case, it is usually used for long-distance signal transmission. Multiple fiber is made of glass fiber with a diameter size of 50 to 100 microns. And we're going to Internet security. And also on the third page, the Internet 802.1x security section. The purpose of the 802.1x is to accept or reject users who want full access to the network using the 802.1x. It is a secure protocol that works with 802.11 wireless networks such as 802.11b, G, and N, as well as with wired devices. The problem is anyone can enter a building and plug their device to a switch or a wall jack port and can possibly connect to a switch and be in your network. IEEE 802.1x is an IEEE standard for port-based network access control. It is part of the IEEE 802.1 group of the network protocol. It provides an authentication mechanism or device wishes to attach to a LAN or a WAN. 802.1x is a very secure method of protecting your wireless network. Each time the device connects, the user configures on the device is authenticated against the rate of service and is given a unique encryption key to change every 90 seconds. Advantage of the central authentication service, attackers can find a misconfigured switch replies changes when someone leaves, is hired, needs critical changes. Authentication service does heavy work, and only one authentication database to maintain. Now, a word form from best of friend, a word from our best friend, Professor Messer. Y'all know him?
As your network grows, it becomes more difficult to know exactly who's plugging in to the different ports. Someone might come in and plug into a port in a conference room. Perhaps as a network professional, you're concerned that that person may have access to resources that you really don't want to give them access to. In those environments, you may choose to use something like 802.1x. This is port-based network access control, PNAC. It's often abbreviated just as NAC, network access control. You don't get access onto the network until you authenticate. Even if you plug in a laptop into a port, you're not going to be able to get anywhere until you provide a username, a password, and the other authentication that's required. This uses a lot of encryption. It uses standard protocols like Radius. It takes advantage of restricting this right at the switch. So this is a very intelligent way of providing access onto the network. This also usually has a function built into it that can perform a posture assessment of the remote device. So as I'm logging into the network is going to query my device to see if I have an antivirus agent running, if I'm running disk encryption, if I'm up to date with all of my antivirus signatures, and it can report that information back to the central controller, who can then make a decision on whether you're allowed onto the network. If you're too much of a risk, we may not provide you access. That's all done with something called a posture assessment. This is not port access at a TCP or UDP level. Those are different kinds of ports. We're talking about physical ports, the ports where you physically plug in a wire into a switch itself. I'm able to restrict right there at that port, and I have to have a very specialized process to be able to provide that level of security. The process of 802.1x involves your workstation. You are the supplicant. You are communicating to a device that is the authenticator, and then ultimately the authenticator will be communicating with an authentication server. So you go into the conference room, you plug in your laptop, you plug in your device onto that Ethernet connection, and nothing happens. Nothing is going to happen until the authenticator sends out a message that says, is anybody new on the network? Has anyone plugged in recently? Is anybody out there that does not have access? And at that point, your workstation can send a message back saying, hi, yes, my name is James. Let me send you that response to that message you sent out. I'd like to have some access to the network, please. The authenticator then talks to the authentication server and says, I got James, he's on the network. I thought you'd like to know that. The authentication server then says, well, James is someone who we can let on the network if he has the right credentials, so please send a message to James and find out if I'm able to talk to him in a private way. The authenticator then sends a message to my workstation and says, okay, are you able to talk to the authenticator? I'm like, absolutely. Here's my username, here's my password, here's all the credentials that I need to get onto the network. The authenticator passes those off to the authentication server, who then checks my username, checks my password, and confirms that I am really who I say I am. At that point, the authentication server has thought about it, says, fantastic, James is somebody who is allowed onto the network. It sends that to the authenticator, who then sends a message to me saying, yes, you are allowed access to the network. It begins to open up the ports. The authenticator then lets everybody on the network know that I'm authenticated. My switch port is enabled. It may even move me to a particular VLAN, all because now it knows who I am and where I'm plugged in. This 802.1x process is relatively complex to set up and get running, but you can see there's a lot of power providing port-level access using these specialized protocols.
You guys will see this video again in the near future. And that's it.